distinguished panelists, members of CAP, ladies and gentlemen. My name is Sonali Maini. I'm an entrepreneur, and above that, I'm a spiritual mentor and practicing Krishna consciousness. I'm an active supporter of the Foundation for Campaign Against Pollution, known as CAP in short. On behalf of CAP and on my personal behalf, I welcome you all to this webinar on plastic recycling, potential and technologies. CAP is an NGO whose mission is to significantly reduce plastic pollution in environment through creation of awareness about the harms of plastic pollution and to educate people at large about the safe disposal of plastic waste. The members of CAP come from a wide spectrum of fields. CAP members include serving civil servants, chartered accountants, lawyers, bankers, social activists, spiritual mentors, journalists, business persons, and above all, homemakers, to name a few. Our aim is to convert our mission into a people's movement through which we change the mindsets of the people and bring about behavioral change towards plastic use and its safe disposal. This is the 11th webinar in the series of webinars that CAP has decided to organize with a view to create awareness about various issues related to the plastic pollution and to evolve practical solutions to mitigate and gradually eliminate this scourge from our beautiful planet. We all know that the plastic pollution is a mammoth problem and one of the greatest environmental challenges that we face today. The plastic pollution impacts human health, harms wildlife, marine animals and birds, exacerbates natural disasters, contributes majorly to climate change, and is responsible for disturbing many ecosystems. Globally, it is widely believed that there are three main R's, that is, reduce, reuse, and recycle, that form the edifice of strategy to combat the plastic pollution. So today's webinar will focus on the third R, that is recycling. The objective of the webinar is to understand all dimensions of plastic recycling. When we talk about recycling, many questions come to our mind. What types of plastics are recyclable? Which plastics are non-recyclable? How many times a particular type of plastic can be cycled? Can and should different types of plastics be mixed before recycling, or should each type be handled separately? How should non-recyclable plastics waste be handled? And so on and so forth. So we are fortunate that we have 5 eminent speakers today. Let us make best use of this opportunity and learn as much as possible from them. With these words, I extend my hearty welcome to Dr. Jitendra Bera, Professor of Chemistry, IIT Kanpur, Dr. PSG Krishnan, Principal Director, CIPT Head Office, Chennai, Dr. Smita Mohanty, Director and Head, School for Advanced Research in Polymers, Dr. Asid Varsi, Advisor Sustainability, and Srirag Kuruvat, Project Head, Greenworms, who have spared their valuable time and made it convenient to participate in this webinar as panelists. I also welcome members of the CAP present and all other attendees to this webinar. I hope their inquisitiveness during the question answer session will make the webinar more interesting. Now, a few important requests. First is, please keep yourself in mute mode throughout the webinar and unmute only when you are called upon to speak. As for the video, it is your choice. You may keep it off while you are not speaking. It will increase the bandwidth availability for all of us. Next point is, please write your questions in the chat box. Please also mention the name of the panelist to whom you are addressing your question to. Also write your name. You may write your question at any time, but they will be taken up at 5 p.m. Next and last, we also request for your feedback on the webinar. After the conclusion of the webinar, an evaluation form will be emailed to you. Please take a minute or two to fill up the form and return to us. The information shared by you will be kept confidential. Your feedback will help us in making improvements in future. So before we commence the webinar, we will watch a short video of less than 2 minutes brought to us by WWF. So I request Anupji to please move ahead with the video. Thank you.
I will share.
Yeah.
You've probably heard about a giant trash island in the ocean, or that poor sea turtle and the straw.
So thank you very much. It was a wonderful video. So now we are fortunate to have very eminent speakers today. First one to share his knowledge and thoughts is Dr. Jitendra Bera. I will now introduce him to you. He received MSc from University of Kalyani in 1993 and PhD from Indian Institute of Science, Bangalore in 1999. After a couple of postdoctoral stints at Purdue University and at Texas A&M University, he joined the faculty at IIT Kanpur in 2003, where he is currently serving as a chair professor. He is elected fellows of 3 national academics, FASC, FNASC, FNA, and recipient of J.C. Bose National Fellowship. His research in the field of organometallic chemistry has earned him several awards and recognitions. He is a recipient of C.N.R. Rao National Prize in Chemical Sciences. Dr. Bera's research interests span synthetic, structural, and mechanistic organometallic chemistry and addresses energy, environmental and sustainability aspects of chemical synthesis. So I now call upon Dr. Jitendra Bera to kindly unmute and speak and share his thoughts. Thank you.
Thank you, Sonali ji. Can you hear me? Can you confirm? Able to hear me?
Yes.
Okay, wonderful. Now, can I have the access to share a file?
Yeah, Anupji will do
You
that.
you can share. You can share. You can share. It has been enabled.
Oh, okay. Let me see if I'm able to. No, I'm not able to share. Let me.
Multiple participants. Yeah, it is. It is enabled from my side.
Uh, wow. I don't want to. No, I'm not able to. Let me see.
Now,
Just a minute. Just a minute. Let me see. Can you say? Can you see the?
We can.
Wonderful, wonderful, wonderful. Sorry for all those things. Let me see. Once it starts, it starts. Okay. My screen is visible, and I
Yes.
believe I'm audible. Okay. Wonderful. At first, thank you, Anupji, for inviting me. It's a great pleasure to share some of my thoughts in this forum, and thank you, Sonalaji, for this very kind introduction. Let me take this opportunity to introduce myself. I'm a chemist. So what I'll tell you is my perspective on this massive issue, massive problem that we all are facing. Um, uh, Now I understand that it cannot be a very technical talk, so it's a so I will hardly give any equation or any chemistry, but let me see if I can convey some of my understanding on this issue. Yeah. Now, whenever we are someone, whether you are advocate or a policy maker, or simply we are interested about this issue, some basic understanding if we have, it is always helpful. You don't need to be a chemist to understand what is something called carbon. We all around, all of you, we see what is carbon. What happens is that if a molecule, if something, a molecule, let's say molecule, I think I'm sure all of you have kids, so you know the molecule. If it is a one carbon, it is called methane. Methane, if you're in the village, you must have seen, sometimes you see fire, that is the methane. Then ethane. For example, if I have 3 carbon, 4 carbon, you know the chemical that is in your gas burner. When you have gas cylinder, that is the 3 carbon, 4 carbon. You go little high, you have petrol, 7 carbon, then you have little more high, diesel, then you go higher, kerosene, then you go many more carbon. What you see is plastic. It's just good to know what it finally boils down and give you this this plastic. Now, this was made by chemist. What are these? 1963, Ziegler and Natta made polyethylene from ethylene. So we start with 2 carbon, we get hundreds and hundreds of carbon. The point I'm trying to make here is that as a chemist or as a scientist, we come up with new discovery, and we believe we have changed the world for good. And it has made our life, the quality of our life, much better. As you all know, plastic, today we can frown upon it, but plastic has made the quality of our life much better. Now, what as a chemist we have to be careful and understand, and as a scientist, that what we make today, tomorrow it will cause us much bigger problem if we are not careful. So as a chemist, as any scientist, as an engineer, we have a responsibility to remind ourselves that what we do. So that is the chemistry part. Now I will go this part little fast, because most of you are here, you have some understanding of what is plastic. We produce just to have the quality of our life better as a consumer is 350 million ton per annum. That is a rough estimation. And how do we do it? We take the petrochemicals and we make this plastic, and that covers all types of plastic. Now, out of that, if you look at it, a major part, 42%, actually you take it as a 50%, as simply packaging material. Okay, and you know that packaging material is simply we use to transport and then we simply throw it, or we have no more use. And then you can see the all other type of plastic where we actually use it, and this is a 2018 number. And let me confess here that all those numbers are taken from some reliable source from the internet. This should be known to all of you that these are not data that I created or I was any part. These are all data, but I have been careful to take those data from a general reliable source. What is India's problem? We are creating 9,200 tons of plastic per day. If you look at the ministry's data, it says we are recycling 60% of the plastic, which I have no way of proving it. Because even if you saw the video shared by Mr. Srivastava, we even globally do not recycle that much of plastic. So anyway, but we produce this much. This is just to give you idea, and I don't have to give you this number. You come out of your house, you take a walk in your neighborhood, you see the plastic pollution problem. Okay, it's everywhere. So my job is not to make you aware of this thing. But these are the issues. These are the number. Is not a bad idea to know. If you look at this, these countries are missing. Okay, the per capita plastic consumption. The left part is 109 is the USA, China, European country, and this 11 is the Indian number. What does it mean? That we actually consume not in the global level, and that is obvious. If you are from a rich country, even if you are a rich person, your consumption is more. That consumption is in all aspect of energy and the material. That's well known. Global average is 28. But what one should know, that as we move forward, the quality of our life increases, our economy increases, we are able to reach to the larger section of the people. So you will see by 2020, the per capita plastic consumption for an average Indian will rise to 20 kilogram per person. Those are very hard number, and these are from a good source. What does it mean by if we consume? So what does it happen? If we consume, we create more waste. Okay, it's these two goes hand to hand. Okay, if you go and buy, let's say your house, you have plastic boxes, but you suddenly decide, no, I need more plastic boxes. Fine, you buy more plastic boxes. Then you create more and more waste. So consumption and waste are go hand to hand. It is important for all of us, because when I look at the, I got a note from Mr. Srivastava and also Sonali did mention that we should recognize our plastic. It is important. I'll come back to you probably a little later that why it is important, but we must know what different type of plastics are. And then now there are internationally figured out or accepted code that tells you that your type of plastic you have. Now you can always, I can always give you these acronyms, which are, I as a chemist I will know, but you will not know. For example, polyethylene, you will see in a bottle it will be written PET bottle. Okay, essentially polyethylene bottle. Then a terephthalate bottle. Okay, so if you are buying from a good, I wouldn't say good company, but if you're buying from a responsible company who gives you the quality of the plastic that has been used to make a particular product. Okay, and then you will see this is called the identification code. That is the resin identification code. Okay, a polymeric material comes to the industry after you make the polymer. Let's say polyethylene. Now that is being treated to make consumable products. You don't buy polyethylene, you make, or you do not buy high density polyethylene. You will see that it is HDP. No, you are not buying HDP. You are buying a bottle of Coke where the bottle has been made by HDP. So it is important, any recycling process, you have to know the nature of the product that you are going to recycle. That is the first step. Okay, because everything upon not that quality and everything cannot be recycled in a same fashion. You have a grocery bag, everyday disposable grocery bag, or you have a bucket. You know that your grocery bag and bucket cannot be recycled in the same way. Now, what I like is this thing that you can see that there are code. What it means that if it is code number 1, this can be recycled. That means your plastic container, jars, caps, this can be recycled. You go to little harder bottle, HDP, for your shampoo bottle, then you see it can be recycled, and it is recycled. You go to polyvinyl chloride, cleaning product, see, those things cannot be, at least with the current technology, cannot be recycled so easily. You go to low density polyethylene, you can see that it's only very little percent of it are recycled. I can go on and anyway, this will be available. You can go and look at it. But what is important is that this column. What is this column? It says that how long, if you keep it in a reasonable condition, how long it will take to completely decompose. Now let me tell you what is the general meaning of decompose. Every day you will make vegetable, and then there will be a lot of waste. Okay, that waste, you keep it somewhere, you will see that will start rotting. Okay, rotting is a process that it is being destroyed by the microorganism, and what it essentially finally it creates, those actually come back to the earth. Okay, now most of these plastics are not degradable, and that is the major point. Okay, so let's say you take a carbon source, they are everywhere, but then you make something, then it becomes completely outside the loop. So you take a source material and then you make something. Of course, you in the process you use it, but then at the end these are completely out of cycle. And you look at the value. HDP will take 100 years to decompose. Polypropylene will take 20 to 30 years. Low density polyethylene will take 500 to 13 years. So you can see that why plastic is a major problem than any other problem. For example, we are recycling a lot of stuff. For example, we are recycling glass. If you go to Europe, they are recycling metal. Coke can they are recycling. They are recycling glass items. They are recycling everything that your household waste is there. Waste is there that are being distributed. Okay. Just a minute.
Professor, I think you will be able to get your question paper uploaded on Hello IITK sharply at 4. Okay, but still, if you face any problem, just
Give me just 1 minute. I am sorry for that.
It's not be visible and the Hello IITK platform, and kindly don't communicate with each other during the entire session. That's all. Okay, I think from who you will be able to see the question.
I'm very sorry for that. Actually, as a teacher, I'm conducting an exam on my side, so that is going on. Okay. Now, so I guess you understand what are the issues, that there are different type of plastic, and it is not a simple way to recycle it. This has been already told by Sonali ji. This is a concept. This is a concept that is for any type of waste recycling: refuse, reduce, reuse, recyclable, rot. What is refuse? If it is not important, you don't get it. For example, I see that I am holding here a very little amount of water, and see, this is the plastic. It will simply go as a waste for so much amount of water. So what you do, you simply don't buy it. You can have your RO, and then you can have a glass or cup and drink your water. And most of you know what I'm talking about here. The problem is that maybe Sonali ji is the expert here. If I have enjoyed something, if I have the access of something, can a society at large go back to unlearn something? For example, I can buy a car which goes in 100 km/h. Now I have given the option that no, you buy an electrical car which goes 30 km/h. Does, as a society, can we unlearn what we had, and then what we are going to go? My understanding, this is the job of the policymaker. We can always appeal to the moral or the conscience of our neighbor, our citizens, but we cannot leave a important problem solely on the conscience of the people. Okay, I believe that there has to be some amount of laws has to be brought, not simply by volunteer basis. If you want to do it, no, I'm not talking about not necessarily on the citizen or the users. It is about the what a company can actually even manufacture. Okay, so it is all sector. Okay, but anyway, I am not an expert on that. I am a chemist, so so let me go to the my part on the recycle. This is a quite complicated diagram. I don't want all of you to go through this, but I'll try to simplify it. When you have a plastic waste disposal, then what you are talking about, two ways. I can go for degradation, I can go for recycling. Now, there is a general understanding. People believe that degradation is the right thing. What do you mean? That I take plastic, I put it some kind of bacteria, so it eats it, and then it finally it creates carbon dioxide in water. And it is so accepted by general people, okay, even the experts. There's a big issue with this. When you make plastic, that compound can also be an extremely high resource material. Now, if you degrade it, you are not going to get same value out of that waste. The philosophy here should be, the waste should not be waste. Waste should be a valuable resource in our society. That only makes it
Dr. Jitendra, you
Yeah,
have got.
you're on mute.
I have unmuted. Yeah, it got automatically muted. Okay. I hope what I'm telling, I'm making some sense here. Okay. So what I'm telling is that as a person who has spent a lot of time on the waste material, disposal of waste material, degradation is really not a good method, because when you degrade, you completely lose the value of that waste. Waste should be valuable. Now, let me say, I'll come back to this point, what I mean, then I go to recycling. Recycling can be physical recycling. What is physical recycling? Is essentially, I will come to this slide, but let me tell you what happens. You take all the waste plastic, they are different types, you segregate them, because as I told you that every plastic is different type. After you segregate it, and then you basically under high pressure, you make them some form without changing the chemical structure. You compressed it, you have some form, and then you try to make a different product from that plastic. Okay, now let me tell you, this is important. Let's say I take a Coke aluminum bottle or aluminum can, then I collect those cans, I clean it, then I make from that aluminum can, I melt it, I get aluminum, and then I again make Coke can. That is a very ideal situation, that I am making the same product from the same source material. Now, most of the time what happens when you take the waste and make something else, the value of that product goes down, but still the material comes back in the loop. So those are the physical recycling. And physical recycling also, as I'll give you a little more details, is about landfill. Okay, now come back to, those are the common. What we do today in India in a larger scale is the physical recycling. What we do not do, but which is important, is here you can see the energy recovery and the resource recovery. And let me tell you again, emphasize this particular point, why this recycling is more important than degradation. Let's say you have collected a large number of polyethylene bag, okay, or that kind of plastic. Now, some plastic has very high caloric value. Let me okay, you may not know what is caloric value. Let me give you something. I give you a lot of different stuff. Maybe what I give you is a paper, I give you plastic, I give you a lot of other stuff. If you burn everything doesn't create same amount of heat. For example, the gas cylinder, the gas you have, if you burn that gas, it has a lot of high caloric value that you heat. Some plastic has very high caloric value. The question is that why don't I use, it is called the energy recovery. I want to get back the energy that is within my plastic. Try to understand that. I am not throwing this plastic and putting in landfill. What I am trying to do, let's say take all those plastic which has high caloric value, I burn it, and then I take that, get the energy, and then with that energy I can do, I can produce electricity, or I can produce whatever it is. There is, the other is thermolysis. Thermolysis, essentially, I burn some plastic, those doesn't have high calorific value, but what I do by doing that, I do pyrolysis. What does it mean by pyrolysis? I break them into smaller polymer. As I told you that, let's say polyethylene, I have 100 carbon or 1000 carbon. I make it, let's say 100 carbon. That is called the pyrolysis. You break down. And then I can use those smaller polymer to do something, make something else. I can make hydrocracking. I do reduction. What does reduction mean? I take those plastic, I treat them with hydrogen gas. It is called hydrocracking. And then I get valuable material. Or I can even take those plastic and I can make them fuel fuel gas. Okay, this is called the gasification. So, so all those are, although done to the best of my understanding, on a much lower level, but those are much more profitable, and that makes the recyclable more affordable. I will come back to what is chemolysis. Now, let's say I have spent some time on this slide, so I will go this part little fast. See that what I mean by mechanical cycle. A industry makes polymer. Polymer goes to a company who makes product. The product comes to consumer. Consumer create waste. We collect the waste. We transport the waste. We do the sorting. We make this. It is called bales. The different types of compressed polymer. We recycle it. Make different product. We make polymer granules. It comes back to the company to make different products. Okay. So this is basically the mechanical way. Let me, because as a chemist, let me tell you a little bit about chemical recycling, and which we do only 1%. But I want to emphasize on this point that there should be much more effort. There should be, people should be investing in the chemical recycling. Okay, and you see that it is only done 1%. I give you only two examples. Forget about, don't worry about if you do not know chemistry. And it is not the job of me to teach you chemistry. But what I'm telling, just know this thing. This is called PET, polyethylene. And what is this N? This N is essentially, see, there is a repeating unit, and this N can be, let's say, 20,000. Okay, that I have this 20,000 repeating units. Now, what we are proposing here, or what people have done, you do some chemistry. This is a molecule called ethylene glycol. Everywhere available. It's a kind of alcohol. You use it in your car so that your car as a coolant. What you get it if you do it, doing some chemistry, you come back to this molecule and you see there is no N. There is no N, as you can see. What we call it? We call it monomer. That means that you had a plastic, you had a 20,000 unit. Now you have broken down into one unit, and then you can again do polymerization reaction, and then you can get back the PET. Okay, so this is a much more cleaner chemical recycling. You start with plastic, you do the chemistry, you make the monomer, and using that monomer, you again make the same plastic. That is one example one can look at. I give you another example. It is not necessary that every time you start something from a plastic and then you breaks it down and come back to the same plastic. It's not necessary. For example, you see here you have a polyolefin plastic material. Okay, as you can again see that there are n number of units. Okay, then you make a plastic waste. So this is your plastic. Now what you can do some chemistry, and you can make this plastic to something called lubricant. Lubricant, you know that in the car industry, any heavy machinery, we use large amount of lubricant or the waxes. So essentially what you are doing, you are making from plastic to another useful material. We call it lubricant or the wax. So this is also an example, a great example of converting polypropylene plastic waste to another useful, valuable material. We also call this as a valorization. Generally, when you start with the plastic waste, the value is low, but we are adding value by converting this plastic waste to a more valuable component. And I can go and give you as many examples you want, but the message here is that you can do an effective recycling of plastic by doing chemical recycling. I want to spend little bit of time on landfilling simply because of the fact that Sonali, please tell me when you want me to stop if I'm taking too much of time. Give me little ahead of time. I'll take 2-3 minutes to conclude after you say that my time is over. Okay. Now,
You can continue. You can continue. Yeah.
okay, just couple of points.
Yes. Yes.
Landfilling, it is majorly done, but let me tell you, landfilling is not a good idea. First thing is that we do not get the value of the waste plastic. The important part is that there is a lot of problem with the landfilling because it leaks, our water become contaminated, our land become contaminated. It's not, and then we lose the value. Some people do support it because it is a one way of doing carbon sequestration, because you are actually taking carbon based material and putting under the ground. But believe me, it's not a good solution. All the recycling I have talked about, still nothing will solve this particular problem. It is called microplastic. For a long use and exposure of plastic, various way, those plastics which are easily you can isolate it, you can store it, you can segregate it, but then by different way it becomes microplastic. That is means the size is below 5 millimeter. This is one of the greatest danger both all living people are actually facing, because it is contaminating our soil, it is contaminating our aqua life, it is contaminating our lungs. There are studies that babies are being born with a smaller lungs because of that persistent microplastic. This is a completely different issue, and that the solution has to come from alternate products, not the recycling part. If we use plastic, this is going to be a problem. I will not go through this problem, but let me I'll take 3 more minutes. Chemist has been a part of this problem. Chemist has to provide a solution, and this none of these problems are individual problem. All those problems has to come integrated problem. We have to integrate all those issues. For example, when you're looking sustainable development, sustainable future, plastic recycling as important aspect of that. What is being said now, that what we have done before, it's a linear model. We buy, we consume, we create waste. That has been our life. This is called a linear. We only keep on creating waste, we consume. The new idea is that we have to go for a circular economy. I'm sure all of you have heard about it. That we have to take raw materials, then we do not come back to the raw materials. We design product, we produce in such a way, we consume, and we repair, reuse, and recycle in such a way that we generate very minimum waste. The system, the product keeps on going to the circular economy. So we have to look into this that way. And there, the one of the issue that has come up is called cradle to cradle. You start with the product, then after you use it, you create a waste. That waste should be the precursor or the starting material for another product. That is why cradle to cradle. You have a product, that is the cradle. You use it, your waste should be the starting material for another product. And that is why we have to look into this issue. The policymakers, they have to look at this issue in a more holistically. I'll not go through this. I just give an example. This is my last slide. I want to give you the example that what I talk about, that when you do this, take a product and then you keep on using it. Let's say you buy a pair of cotton jeans. Okay. And you know that anything that you use, its value goes down. The material value goes down. you buy a cotton jeans today, after 2 years, repeated cleaning, this thing, it is no longer, you cannot wear it. So what you do, you take this thing and then you make it material for furniture stuffing, because that may not be for wearing, but that will be for stuffing the furniture. You use it for another several years. Then you make it, then when it is no longer stiff, then you make it for insulation material, because there you do not need to, you only need the electrical property. And after that, what you do, when it is no longer can be used as insulation material, you simply degrade it in such a way that it goes to the earth as a nutrients, because it has still carbon, it still has a nitrogen, phosphorus, whatever the element is there, it goes as a nutrient. So this is called the cascading. So there is a thought process that any recycling of plastic or anything that we are talking about, we may not be always come back to the cyclic way, but we can actually do it in a cascading way that will essentially work on for reuse, recycle, reduce, refuse. Many of those can be covered if we look into this cascade mode. The last sentence is what we are looking for, is that if you make a product, please follow up that product, that we have to know the complete life cycle of that product, and only knowing that we may be able to provide some solution for sustainable way of doing things. But I will just keep this, but I will wait for any questions or queries you have.
So thank you, Dr. Jitendra Bera, for such a wonderful session, for wonderful information you have given. Questions, as we discussed, that it will be taken at the end. So now,
Absolutely.
yeah.
Absolutely. Please go ahead. Thank you.
Yeah, thank you. Thank you so much. Thank you. So now I will introduce Dr. Smita Mohanty, Director and Head, School for Advanced Research in Polymers. Dr. Smita Mohanty is the Director, Principal Scientist, and Head of the CIPT SARP LARPM Bhubaneswar, Department of Chemicals and Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India. Dr. Mohanty has more than 16 years of experience in teaching, research, and technical consultancy. She has been the key to Industry Connect, bridging academic and industry. She has mentored group of faculty, scientists, and PhD scholars in their ventures. She has been the author of more than 200 international publications, authors of 16 books, book chapters with leading international publishers, and several patents to her credit. She is also the recipient of several prestigious awards like National Award by Government of India in appreciation towards technology innovations in petrochemicals and downstream plastics processing industry, Outstanding Research Faculty Award by Scopus Careers 365, etc. So Dr. Smita Mohanty, may please unmute and make her presentation. Thank you.
Thank you, Madam Sonali. I am audible. Am I
Yes,
audible?
yes.
Okay. My screen is visible.
Yes, yes, yes.
Okay. So, first of all, I would like to thank all the organizers for giving me an opportunity to speak in this beautiful platform. So my topic would be whatever Professor Bera has already highlighted. Mine is on single-use plastics, opportunities and challenges. So I'll just go through whatever I have. I have. Now, first of all, as all of us know, that plastics are versatile material because of its lightweight and cost effectiveness, easy availability and processing, corrosion resistant material, sustainability. Now, if you see today in layman's version, we find what is a plastic, then people will tell that it is a bucket or a carry bag. but to the understanding that to the common platform, plastics are used in manifold applications, including your transportation sector, agriculture, healthcare, then your all your energy harvesting system, apart from the packaging application, which we find it in our day-to-day life. Now, if you see the sector-wise consumption, as already Professor has highlighted, but the major sector, major consumption is in the area of packaging, followed by your infrastructure, then your automotive, agriculture, and then the other sectors. So whatever we see today in the litter, or whatever for which, whatever reasons for which the plastics are a menace to the society, it's all because of the littering prospects and because of the maximum use of packaging applications, what we find it in case of the plastics. Now, as regards to the plastics per capita consumption, as you can see here, in India, it is now, as per the 2019-20 report, it stands as 16 kg per person. Now, as vis-a-vis your global average, 28 kg per person. So why
Dr. Mohanty, sorry to interrupt. Your next slide is not visible. If you can
this is
move
not
ahead.
visible?
No,
This
like it's still on the first slide. So you can you will have to move it to the yes. Now it's visible. Thank you. Thank you so much.
it's okay.
Yeah.
Yeah.
Yes.
Also, can you make it full screen?
I
Full
made it full screen, sir. Now is it okay?
No, it is not showing as a full screen.
Uh,
But slide is changing, so you can go ahead. But it is
yes.
not visible as a
Okay.
full screen, at least to my.
It's
No.
already in full screen actually.
Yes, we can see it in a full screen. Maybe.
Oh,
Okay.
maybe I am not able to see. So please go ahead. Go ahead. Don't worry.
Yeah. So it's 16 kg per person if you see in case of in India, whereas if you see in US and other advanced countries, it is more than us. So why they are a menace in case of your in India? Why exactly they are blamed? Why exactly what happens basically? So now, during 2018-19, during World Environment Day, there was a lot of propagation as regards to single-use plastic products. So what are these single-use plastic products and what are the concerns? Now, these products, as the definition says, like the carry bags for vegetables, groceries, etc., parcel services, etc., which are irresponsibly, which are littered and directly it is in the environment or it is disposed of. That means when you use it for once and when you throw it away, that falls under the category of your single-use plastic products. Now, because these plastics are highly sustainable and they are difficult to degrade, so they tend to remain in the environment. And ultimately what happens, the land-based resources or the litter, what you find, that is being that goes into enters into your marine food chain and choking your animals and birds to death, what we are exactly now finding it, polluting the environment. So all these things happens because what we say is that these are all man-made. We need to have an organized system. We need to have a proper system of collection, source segregation, and then conversion and recycling technology needs to be adopted so that these concerns, whatever we are having it today, that is being, that is being addressed. Now let's see this. This is a statistics which are, it's a 2019 statistics wherein you'll find the major companies which make a quarter of world single-use plastics. Like we have Saudi Aramco, we have Indorama, we have Sinopec, we have Dow, and then we have ExxonMobil. So these are the 5 companies. If you take the statistics, they make a quarter of world single-use plastics. Now, so as Professor has already defined what are the different categories of plastics, like how best you can categorize the plastics. Now, we have basically 2 different categories. One is your thermosets and then you have your thermoplastics. Now, as regards to the type of the plastics based on their recycling code, we categorize the plastic as safe choice, safest choice, avoid, and then use with caution. Like for example, if you come for polyethylene terephthalate, what you normally find it in water bottles, that is called as your PET bottles. Now they are safe choice. Similarly, if you have high density polyethylene like milk bags, detergent bags, carry bags, the containers, they are safest choice. Why do we classify safest choice? Because they bring in a lot of versatile, they can enter into different
Sorry,
categories.
Dr. Mohanty,
Yeah,
again, your slides are not changing. Yeah, yeah. Thank you. Thank you so much.
this is okay. Yeah.
Yeah, yes,
So
yes.
because of because of their ease of propagation, because of their ease of utility, what happens basically is that they are categorized as they are categorized based on like safest choice. Similarly, if you come across PVC, which is normally used for your flexible cables, pipes, floorings, etc., we call it as avoid. Why we call it avoid? Because recyclability options are limited. End of the day, when you go for incinerating it or any kind of major thing which you come across, under those conditions, what happens is that you have these are not recyclable, which we can say. We come across polypropylene or low density polyethylene, we call them as the safest choice, because in today's scenario, maximum of your biomedical waste, like it is in the form of a, whether it is a PPE kit or anything which has come as a savior now in during the COVID times, they are the safest option. Why? Because you have hygienity in that, because you have you can easily recycle them, you can easily convert it back. It has got a closed loop system or a circular economy to that, which I'll come in the later part. Polystyrene, like lot of poly foam packaging you come across, teacups, ice cream cups, etc. Because of the limited recyclability option, we call it as avoid them. And others, under the others category, you find all kinds of multi-layer plastics, thermosets plastics. These are categorized as other kind of different other kind of the plastics which we come across. Now, so going by the definition, if you go by the definition, what are these single use plastics and how best you can define these single use plastics? Now, so we had earlier during 2018, we had taken up with UNEP definition, with UK definition, and with UN definition. As a common definition, we took it what is the, like during September 2019, we referred to as the disposable plastics or your use and throw plastics, which includes the items which can be intended to be used only once before they are thrown out or they are being disposed of. But if you look at the new plastic waste management, which has come very recently, so there single use plastic has been defined and categories of items have been also defined, which are to be banned in a phase wise manner. Like you have earbuds, you have plastic sticks for balloons, then you have plastic flags, the candy sticks. So all these are categorized under your single use plastics. They have been categorized as different environmentally problematic products. So on account of that, the ministry or government of India has planned for a phase wise ban on all these single use plastic products. Now let's see, this is a study which we did it CPET, and through CPET we had done this study basically to see that how what category of plastics falls under under your environmentally problematic and you need to avoid them, and what are basically based on 5 factors of utility. So based on that, what we did is that we categorized based on hygienity, product safety, essentiality, social impact, and economic impact. Let me cite an example in this regard. Like for example, if you take a blood bag or if you take any kind of biomedical application where the plastics they play a vital role. So under those conditions, these factors, 5 factors of utility comes into picture. Like you have hygienity, you have product safety, you have essentiality, socio-economic impact also you have. Similarly, as regards to the adverse impact on environment, let us take the example of a small tiny chocolate wrapper. So what happens basically in that case? The wrapper, the small tiny chocolate wrapper, the rat picker has to bend down several times to lift it up if it has to enter into any kind of recyclability option. So naturally, it has got some of the, like, collectability becomes a problem, recyclability again becomes a problem. So it has got a environmental impact of alternate materials we have to see, and that is the most littered variety. So based on that, we classified the different categories of single-use plastic products, and around 50 categories we have identified, and based on that, the recommendations were submitted to government for categorizing the single-use plastic products which are basically environmentally problematic, like your thin plastic carry bags, the wrapping films, the cutlery foamed cups, or you come across your earbuds with plastic sticks, straws and stirrers, your small plastic bottles, cigarette butts, EPS, or we call it as your expanded polystyrene. So those category of those category of items are environmentally problematic. So we suggested that these can be easily banned. Coming to the next thing, as you can rightly see, in India, plastics are defined by their convenience, affordability, durability, but the end use, as you can see in my slide, that the end use, however, it enters into the major food chain and it becomes problematic at the end of the day. Now let's go to the next thing. What are the reasons to refuse these single-use plastic? So people say that it is made from fossil fuel. Yes, made from fossil fuel. It has got huge carbon footprint, and like professor has already shared, that prolonged exposure for 100 years. So because of its durability, it is again a problematic thing. Then small percentage is recycled, like he has rightly mentioned. Till today in India, chemical recycling is at infancy stage. Most of the recycling technology which you see in the country is basically your mechanical recycling. Then accordingly, when you burn out these kind of plastics, then it pollutes the environment, leaches the toxins, kills the marine animals, enters into the food chain when you litter it irresponsibly. Now, what is the status of these kind of single-use plastic in India? Like you see, it is a 100,000 crore industry with 13.4 million metric tons per annum, growing at the rate of 10.5% CAGR. And strength, today we have 50,000 processors and 7,500 recyclers. Disposal, only 60% is collected. Remaining 40%, what we find is essentially littered, and what we see today in the environment is the 40%. That constitutes your multi-layered plastics and other your carry bags, the chocolate wrappers, and other things, or your foamed plastics, what you can see. So those are being littered. Now, so this is a situation of plastics in India today. Like a man is asking for for fish, then he's asking, "May I have a carry bag?" Then then the shopkeeper says it's inside. So, what is the scenario? Just you can imagine. It is all because of the littering situation which we have in the country. Now, this is a statistics which I have taken it from Central Pollution Control Board. Like for example, in a day, plastic waste management scenario, if you see, 25,940 tons per day of plastic estimated waste is generated. 60% is collected. Let me tell you, what is that 60% which is collected? That is essentially your PET bottles. Why it is collected? Because in India is successful, 100% successful in recycling of PET. And mostly today, whatever your textile garments, your sports apparels, you find it that is made out of your PET. So it is easily being recycled into textile fabrics. So that is what it is collected because of the systematic subsidy system, because of the systematic arrangement which we have it. So that is why what we did is that the collection strategy is better off in as compared vis-a-vis the other plastics. 40%, which is a challenge, like all your Lay's chips packets or Maggie wrappers or any multi-layered packets, atta packaging, what we do at the end of the day, that is being littered. That is being found in the litter, that is being found in the environment, and that poses a problem during your recycling option, collecting option, end of life disposal, or whatever you may see. So this is the scenario which you find it in India. In India, the collection, the plastic waste management, thanks to the rag pickers, or we can say the Safai Karmacharis, they are, I can say, they are the major stakeholders in today, whatever recycling is happening. It is because of them. And you see in US, in the right hand side of my slide, like how organized system of your waste management we have. Now, what is the use of single-use plastic ban in India? This is again another problem which is being throughout, which is being noticed. When we did a survey, we could find that plastic use, single-use plastic products are, although they are banned, but still it is being prevalent in majority of the streets, whether it is in the form of thin carry bags or anything. But still, so awareness needs to be done. Awareness programs needs to be done. How to amicably use it, how to go about for different categories of applications, what is the end use, and how to dispose it off. This is the waste management scenario. What you see, 0.148 millions per day, tons per day, out of which 54 million ton of your solid waste is there our country generates. So what we have, what are our strengths? Our strengths, essentially, we have waste treatment plants 1480, we have biogas plant, we have waste to energy plant, we have also MRF facilities projects which we have. Then we have your construction and demolition plants. So strength is there. Only thing is that we need to have a proper mechanism for amicable collection, and then subsequently it can enter into end of life value addition of the different products. Now let's see, another thing is that there is a EPR mandate which has been recently released by Government of India during October 6, 2021. What is that EPR mandate? EPR is nothing but your extended producer's responsibility. That means if today ITC is producing its own share, so it has to take back the waste or the plastic waste which it is releasing to the market. It has to take back that plastic waste either in the form of some value addition or whatever recycling he is preferring, whether it is mechanical recycling or sending it to some waste to energy treatment or anything. So that is basically your EPR or your extended producer responsibility. So far, what is the challenges? Although EPR, the new mandate has come, but still we lack infrastructure for primary collection. We lack the recycling and the processing facilities, large percentage of unbranded litter. So whatever litter you notice it today, many of the things you will find there is no recycling code to it. You never find any 1 to 7 code, although we have in place, but that is not defined. Strict monitoring and control is required. Then recycling versus waste to energy and co-processing plants. So what are these situations, what we see in India? Now let us see some of the value addition. This is an interesting slide which you can see. A thriving informal market is already, it is there in India. Like for example, PET bottles, as I have shared, that it is widely being converted into apparels. Similarly, milk pouches into Barsati film. So, and oven sacks into Nivar patti, battery cases into luggage, plastic carry bags into mats, PVC pipes as shoes. So we already have a jugaad mechanism in India, in the country we already have. Only thing is that this informal sector needs to be further promoted with some kind of subsidy or certain kind of things, so that at the end of the day we get a value addition out of the waste which we generate. Now, what are the other things which you find it? There are also several other alternatives. For example, some of the other alternatives is that you have your bamboo utensils or your bee wax food straps, stainless steel straws, and alternative materials, like you have a lot of biodegradable compostable polymers are in place, like for example PLA or PBAT based systems, or bioplastics which are made from modified starch, or BioP or your BioPET. Those things have also come across. Now let's see some of the global developments which has come. For example, now of course recently we had seen one of the companies in India, that is your Uflex. It is in Noida. They have come up with shampoo pouches, or you can say shampoo made out of your cardboards. So paper bottles which have a proprietary coating and that repels water. Like L'Oreal, it has reduced its plastic usage by 45%. Similarly, you have a grease resistant paper coated tube. And ITC has come up with the cups, paper coated cups, but those cups are again plastic free, they call it. They have a oligomer coating into it, and those kind of coating, it protects from the barrier properties are intact. Some of the other things, like for example, Coca-Cola has come up with a shrink or a stretch film for holding the cans together. This is again another one more development which we noticed it, that is Dell. Dell has partly replaced the expanded polystyrene with bamboo and wheat straw with and a cardboard based packaging. And similarly, we found the personal care products like bamboo toothbrush in cardboard box, plates and bowls. Already we have a past history, like all the plates and the bowls made out of leaf. We already have it, banana leaf or any kind of leaf. We have all those things in place. And then now people are promoting many of the things, they are being promoted with a fine layer of coating, so that you get a easy easy leaf stitched with a natural thread and a layer of paper and a layer of coating. Pinatex, again leather, it is a from waste pineapple leaf fiber they have made. And bamboo straws, these are already there in place in Karnataka. You'll find a company has come up with bamboo based straws to replace the plastic straws. So I mean the potential is there, and but we need to have some more identified activities where we can it needs to be promoted, some more of R&D which needs to be promoted, so that these kind of developments are intact. Like another thing, in order to have a plant based coatings, which is again instead of a wrap plastic which is being wrapped in all kinds of perishables, fruits or vegetables, you can add a coating to the vegetables or the fruits, and that mimic the fruit skin. That is already in place by Appeal USA. And then Bold Threads, they have come out with silk protein. And milk based protein similarly has come out by Q Milk Fabric, wherein you will find a water soluble, edible and a biodegradable thermoplastic pellet or a wrapping film made out of it from Lactips, France. Other applications, for example, KFC has come up with a edible wrapping paper to wrap the burgers and other things. Cutlery Bakeries India, they have come up with some edible spoons by baking a dough consisting of sorghum with some additional wheat flour. Edible coffee cup, like from a Cup Bulgaria, they have come up with some of the items which has come. And other global developments, like for example in Sweden, they have come up with 30% of your bio-based wood fibers. So we can use other fibers like jute or any other things which are a bamboo, which is readily available, and these can be easily blended with the plastic material. And so 30 to 40% you are replacing the plastics with the natural resource. So these are some of the applications. So at the end, if you see what are the strategy for disposal of the plastics, number one, instead of banning it, what we can do is that phase wise ban those plastics which are environmentally problematic. So we can use reduce, reuse, recycle, recover, redesign and remanufacture. If you see the new EPR mandate which has come up, it is exactly, it focuses on the same thing. Like you have to reduce some of the plastics which are really environmentally problematic, reuse the plastics materials or the products which has got potential for reusing them, recycle it, whether it's chemical recycling or it's waste to energy, whatever it is, but follow a recycling path, recover it, redesign. Like for example, in case of your multi-layered plastics, where you have different family of plastics, there we can substitute it with some of the same family of plastics, so that amicably it can be recycled instead of incinerating it, and remanufacture it. So these are some of the strategies which we come across as regards to the disposal mechanism of the plastics. Some of the ways forward, like we can go for innovation of the design of the plastic product, marking of the single use plastics, which is a very, very important thing. Still we have the unbranded litter, collection and segregation requirements which we need to specify, like there has to be door to door source collection of single use plastics, awareness to littering to avoid littering, segregation of the waste material at source, collection of compostable, like I shared some of the biodegradable polymers carry bags. Now we are noticing in the various kinds of shopping malls and other places. So these kind of compostable and oxo biodegradable products needs to be collected separately. And then promoting sustainable plastic recycling business models, this is one of them. EPR and circular economy, which is also already there in place, but we need to strengthen it. and there has to be more and more industrial composting facilities in the country. We should introduce some of the financial incentives and more funding support, obviously, for research on new developments. Some of the unconventional opportunities, I will not share much of this. This is waste to plastic, where waste plastic as a binder in road construction, where normally we are using it because it improves the performance of the roads. Similarly, plastics also act as a waste plastic as a hidden fuel, which we can notice it because of the embedded energy of the polymers. And this is a example of a constructed eco-friendly structure using the discarded, it's a jugaad thing again. So at the end of the day, as per the PWM notification 2021, SUPs as a contributor to marine litter, and we should phase-wise ban or those plastics which are problematic, not everything. Thank you.
Thank you so much. You can take water. I hope you're okay. Yeah. So thank you so much, Dr. Smita Mohanty. It was wonderful. It was so wonderful. Like your explanation, your presentation was amazing. Lots and lots to learn from the PPT. Thank you so much. Thank you. So now we'll go ahead. I will move ahead. I will now introduce Dr. PSG Krishnan, Principal Director, CIPT Head Office, Chennai. Dr. PSG Krishnan did his MTech and PhD in IIT New Delhi. He is currently working as Principal Director, Technical Support Services and Business Development in CIPT Head Office, Chennai. Prior to joining CIPT as Chief Manager, Technical in 2010, he was working as Joint General Manager R&D in Futura Polyesters Limited, Chennai from 2005 to 2010. Earlier, he worked as research scientist in Institute of Materials Research and Engineering, IMRE, Singapore for 6 years. He's also nominated as adjunct professor in Durban University of Technology, South Africa. He has about 50 research publications, 6 book chapters, 5 Indian patents, and 1 US patent to his credit. His biography is listed in Marquis Who's Who in the World and Marquis Who's Who in Science and Engineering. I now request Dr. PSG Krishnan to unmute and present his ideas. Thank you.
Thank you for giving a wonderful introduction. My voice is audible?
Yes, yes, yes. Clearly.
My screen is visible?
Yes, it's visible.
First of all, I thank Founder Director, Mr. Anup Kumar Srivastava, for inviting me to give a talk for today's webinar. Apart from this, I want to also thank him as well as appreciate him for putting the right title, Campaign Against Plastic Pollution. Because if you see that many people always say no to plastics, rather saying no to plastic pollutions or no to plastic littering. I really appreciate he has put the right title, rather putting a campaign against plastic. If you see that in many places, in many cities, you say you can find that they are saying wrongly say to no plastics, rather saying no to plastic pollutions or littering. For that, really, I appreciate the Founder Director for putting the right captions for his organizations. In today's talk, I will be talking about the potentials and methods. Many of the points were already discussed by my predecessors, both by Dr. Mahanti as well as by Professor Jitendra Bera. Anyhow, some of the things I will avoid it, rather repeating again. If you see that, so far we have produced 18.2 trillion pounds of plastics since 1950s. And that is equivalent to 1 billion elephants, 8 million blue whales, more than 8,22,000 Eiffel Towers and 25,000 Empire State Buildings. So much of plastic we have produced so far since 1950s. And you know that why it has become a so versatile material, that it is having all good things. I need not to say that, everybody knows it. It is easy to process. It is non-toxic, tough and durable. You can manipulate the properties. If you want to enhance the properties, you can do that. If you want to reduce the properties, you can do that. If you want to enhance it, you put in a reinforcement either with a glass fiber or a carbon fiber or a natural fiber. And if you want to bring down the properties, you put the fillers and then manipulate. Such type of manipulations is possible. Apart from that, you can make it a fire retardant, and then it is resistant to microbes, and then it is having a good weatherability, as well as it is practically maintenance free, reuse and recyclables. Everything you get it at a very, very much cheaper price. That is why we have produced so much plastics over the years. And this is because it gives energy saving, it's eco-friendly, economical, and these things and all. Nowadays you may not be able to see any wooden crates, which earlier you can see that for all the Coca-Cola, Pepsi drinks and all. Today's hardly you find that. You will find that you will only see the plastic crates. And then the nowadays also you can see that no wooden furnitures. Everywhere you can see the plastic furniture. This helps to stop deforestation, and is economical both in terms of cost as well as weight to performance balance. And apart from that, you can do a recycling, and if you want to recover the energy, that can also, you can do that from the plastic waste. And if you see that the waste is generated, it's based on the service lifespan. The main culprit is a short life. Example, carry bags, woven sacks, bottles, disposable cups, fridges, and biomedicals. The long life, that is not a major problem as of today. Maybe this problem will come maybe after a few decades, like chairs and all, maybe chairs and then pipes, IT components. Those things are a long life, whereas the short life things is hardly, it's meant for few hours. For example, the carry bag, if you see the lifespan, it starts from the shop and then it ends the moment you reach the house. Therefore, that gives more problem to the plastic waste. And then that is what Dr. Mahanti was also talking about, the single-use plastics. And if you see that the single-use plastic, if you see that how the countries are generating, India is generating 4 kgs per person, whereas the Australia is 59 and the United States is 53. So much single-use plastics are being produced, being discarded, or being generated and then discarded. And this is not a new scene for everybody knows it. You might have seen such similar scenario. Therefore, we have to look for solutions rather just like that burning and spoiling the atmosphere. The most favored options for that, you have to reduce it, lower the amount of the waste generated, or you repeatedly use the materials, or go for recycling. You can make new products, or if you are not able to do that, you try to recover the energy from the waste. And the least options is the landfill, where the previous options are not feasible. Then go for the landfill, which is the least favored options, and finally leave it to the landfill. And this is the recycling. If you see the recycling symbol, this everybody might have seen that. This was developed in 1970s by a 23-year-old student, Gary Dean Anderson. He is the one, he designed this symbol, and these are the one which for the upcycling, and then this is for the downcycling. And then if you see the definitions, The recycling preserves the natural resources, it saves the energies, reduces the greenhouse gas emissions, and keeps the toxins from leaching out of the landfills. People readily send it to the landfills, but finally what happens that over a period of time, the leaching takes place and then leads to the toxins. And if you see the how the recycling concept started, if you see that initially a lot of plastics, whatever was created, that everything was going to the landfill. And once there was a shortage of landfill in 1980s, then what they did that they taken all the waste, they put it in the Marlboro garbage barge. They were traveling from the North America to the South America, because it is also human nature. When you don't want, you always throw to the neighbor's place. Same thing they did in the North America. Therefore, when there was no space in the New York, they put every waste in the ship, and then they were taking that one to the North Carolina. But they are all, they Tanzania also, they refused it. Then finally they were trying to dump it to the Mexico. Mexico refused. Then it was going to the South America, Belize, then Bahamas. They also refused it. Finally, it has gone to the New York. Then finally they thought that instead of putting in the landfill, we have to look for some alternate options available. Really, we should appreciate that they have not sent to the developing countries. Otherwise, we would have just collected and filled it, put everything in our landfill, and we would have spoiled it. Since they refused it, it has gone back to the New York, and finally they started developing the recycling concept. These are the symbols. Everybody, my previous speakers, both the Professor Bera as well as Dr. Manti, they were telling that. And if you see these symbols, a few things I would like to say that there are a lot of misconceptions going on in the internet. Many of my students, they asked me because they are thinking that 2 means you can go for the 2 times recycling and 4 means 4 times recycling, but actually it is not so. The number is meant for the polymers. If one means PET, 2 means HDP, 3 means PVC, 4 LDP, 5 PP, 6 PS, because these 6 polymers, they are the major contributors to the plastic waste. That's why they are given the names. The rest, they put it as the others. And also, there was no confusions as far as this number is concerned. Whether a PET bottle is produced in India or in America or in Europe, the bottle is always coded as 1. It is not like a gallon where the US gallon is different and the UK gallon is different, and a lot of confusions is going on. But luckily, people have not muddled these numbers. Throughout the world, they are using the same number. Therefore, any layman can easily segregate these items when they go for the segregations. And if you see that the plastic waste, when it is generated, you have to see that if a plastic waste is generated in the shop floor, it is a very straightforward. You can do the recycling because there is no need to go for any separations, or you know that what kind of material is produced it. Because in the shop floor, if some material is rejected, then instead of throwing to the garbage, you can go for the recycling. But when it goes to the consumers, then a lot of problems comes, and that leads to a lot of cost, as well as the collections is becoming a problem, because nobody knows what kind of material it is, and then how they abused those items. That's why this number helps for the manual sorting very easily. And then if you don't do the plastic waste properly, it spoils the beauty of the city, choke drains, and then make public places filthy. And when you burn it, which is a very common scenario in Indian cities, it causes air pollutions, and it interferes in the waste processing facilities, and then it also causes landfill operations. The recycling which are not doing as per the norms, it always leads to the hygienic problems to the environment. If this is the recycling of the plastic waste, you know that where these things you collect it, the manual sorting, they do it based on the numbers. The person can easily do that. This is, if you see that in Indian scenario, this is easy to do for a manual sorting. But the problem is that there may be a human error may occur. And then this is suitable only when you want to do a sorting for a smaller scale. but it gives the employment to a lot of the workers in India, and it is a better options in India. And then later on it goes for the baling. You crush it, then you do the washing, then regenerate, make a semi-finished products, and then make an end products. This is the way they do that. Instead of going for a manual separations, you can go for an automatic one. Either you go for a magnetic separations, where you can easily segregate the ferrous metals from that of the other one, these things, or go for an eddy current separators, or go for a sensor based separators. Sensor based separators is the one is very you have to invest a lot of money, but it is a foolproof. There won't be any error, but you cannot do in a smaller scale. Whenever there is a lot of waste is there, and if you have to do for the segregations, then separator, especially the sensor based separator, is the best option. The various recycling, if you see that, the primary recycling, secondary recycling, tertiary recycling, and the quaternary recycling. The primary recycling is the one when you make the product and when you do the recycling, you will get the same similar characteristics like that of the original, that is known as the primary recycling. Whereas the secondary one, you make from the waste, you make a different characteristic material, that is known as secondary recycling. And from the waste, when you make the monomers, basic chemicals and fuels, then it's known as the tertiary recycling. And when you try to retrieve the energy, then you can call it as an quaternary recycling. This is the downgrading, that is the downcycling, making the plastics sacks to a Nivar patti, that people do that. And then this is also another example for the downgrading, where the battery boxes, later on it is used to making the different kinds of luggage suitcases. These are all done by the mechanical recycling. Not much technical knowledge or know is needed. It is easy to do that. But the problem is that when you want to go for a mechanical recycling, you have to see that whatever the products which you are making, that should go for the non-food contact applications. If you want to make it for any food contact applications, then it is better to go for a chemical recycling. Like Professor Bera was telling, that chemical recycling, making the PET and then trying to do the glycolysis and then trying to make a BHET, and rather then later on you go for the polymerizations. That is one way of making a chemical recycling one. Another way now in our Futura polyesters also we are doing recycling. From the PET waste, what we were making is that PET waste, instead of going for a glycolysis, we were treating with the butanediol and making the PBT, which is used for all the automotive applications. Rather making a PET, go for a chemical recycling and making a PET, we were doing the PET treated with the butanediol, and you get the PBT, and then the byproduct will be the ethylene glycol. That we were doing that. Therefore, that will become a value additions, and from the food packaging waste, you can go for an material which can be used for the automobile applications. The other one is that the PMMA, which is a scrap, you can treat it with the 400 degrees centigrade in the absence of the oxygens, and try to get the monomer, especially the MMA, and you do the better distillations to get further impurity. This is the way they do the tertiary recycling, or it is also otherwise known as feedstock recycling. I was told that a lot of entrepreneurs are also there. That's why I made it somewhat simpler, and then as well as they should also have what kinds of recycling and all those things. This is why I was telling about the PET chemical depolymerizations. Not only from making the PET, you can go for the BHET. You can also try to make an ammonolysis and then go for an amide, or make it an hydrolysis, make it a rethalic acid, or methanol, make it a DMT. Or go for a glycolysis, which professor was telling it to make a BHT. And if you make the polyols, then these polyols can be used for making the polyurethanes by treating with the diisocyanates, or by treating with the malic anhydrides, you can also make it USP, unsaturated polyesters. Therefore, from PET, you can either go for making a polyurethane or a USP, or you can go for the DMTs or amides or whatever, you can do that. This is the various kinds of things which is possible from the PET. This is another one is the pyrolysis method where the people make it the six. This is a waste plastic because usually if you see that this waste nobody touches. If it is a PET bottle that fetches a lot of money, people take it and then they sell it. Whereas these type of things, the waste, nobody touches it. For these type of materials, especially the small carry bags and unwanted things, the best options is a pyrolysis plant. You can install that, and if you do the pyrolysis, especially pyrolysis is a method where they do it in the absence of oxygens, but here to make it more self-sustaining, they allow the small amount of oxygen and they make the fuel oil, and this fuel either you can sell it or you can try to use it small amount for making the system running it, and whatever the carbon black that also comes as the byproduct. This is when you do the pyrolysis of the plastics. Then when you do the pyrolysis of the rubber, because a lot of waste rubbers is being nobody use it, the best options is to go for the pyrolysis. Apart from getting the fuel oil, you will also get the steel wire, which is used for the reinforcement for these tires, that you will get it. Apart from that, the carbon black is also used in the tires, that you will get it. Therefore, for these type of waste tires as well as these things, the pyrolysis is the best method. And whoever invests it, they will be able to get an ROI in about 3 years time. And this is what the options are available for these methods. And the carbon black which you got it, either you can grind it and you can use it for paints and inks, rubber products, or you can brick it and then use it for the cement plant, brick factories, or the glass factories. And this is the one. The other options is the recovery of the energy. And this is the Pollution Control Board. Central Pollution Control Board has approved this process because the plastic contains a lot of, it has a lot of calorific value, even when compared to the coal. Coal is having only 29 megajoules per kg, where the plastics is having 45. Therefore, these types of waste can be very well used in the cement industries, in the clean, for recovery of the energy. And this is being practiced in many of the cement plants. And the another one is that nowadays the recent inventions is that from the plastic waste they were making the filaments, and these filaments were used for the 3D printing. This will give a lot of value additions, as well as it can use the options of using the waste for the high-end applications, especially for the 3D printing. That they were doing it. And Professor Bera was also talking about using the plastic waste, making some waxes, using the catalyst, metal oxide catalyst. Same thing here, from the plastic waste, you grind it, extrude it, make a filament, and then go for the 3D printing. For such type of newer applications is also being developed and being, it is all in the infant state, but anybody who wants to see that, they can explore more on these things. And this is the one, another value additions as well as for the upcycling. The earlier one is also a good example for the upcycling. The upcycling is the one, you are making a highly value added products. Apart from that, there needs a lot of creativity is also needed. Therefore, from the 10 plastic bottles, if you make a very good a branded t-shirt, you will get a lot of money also. At the same time, you are using the waste material for making a branded t-shirt. This is one more example for the upcycling methods, apart from the 3D printer, as with printed filaments, as well as for this type of making t-shirts, and 10 plastic bottles is enough. And another example is that using the plastic waste for making the roads, it reduces the bitumen by about 10%. And if you see that the cost also comes down for making a single lane road by about 5,000 kilometers. And then if you see that in the year 2015-16, 7,500 kilometers of roads were used using the plastic waste. And if you see the fatigue life of the roads, there is an improvement. And then if you see that the skid resistance, everything is much better than going for a straight for bitumen roads. Instead of that, you go for the plastic plus bitumen combined roads. And if you see the amount of plastics needed, 8% is needed, which is need to be added bitumen. The beauty is that the bitumen softening point as well as these type of polyolefin plastics, they all well within those range, therefore making it easy to use that one. And 850 kg of approximately bitumen is needed, and then the rest you can use the plastic and you can have the savings. The amount of plastics is about 68 kgs, and they say that you will be able to have a the cost benefit also apart from the better applications. These are some of the roads which they have done it in many parts of the country. This is one which they have done it long back in West Bengal, and in a lot of places in Tamil Nadu also they have tried it, and it's being practiced. And if you see that, these are the plus points of the making the plastic roads, but there is also disadvantage. The problem here is that the materials with the low molecular materials which are used in the plastics, they will start leaching it. Therefore, the toxics which are present in those co-mingled plastic waste will start leaching from the road and it will go to the earth. That is one of the major disadvantage of making the plastic roads. Apart from that, when there is any PVC contaminations and all, when you do the road laying process, then it leads to the HCl gas generations and that gets released. Apart from that, then once if it is laid, they are not very inert, which I have already mentioned it. Okay, and if you see that by the year 2050, the lot of plastic waste. Now they expect that there will be 12 billion tons of plastic waste will end up in landfills, the natural. That much potential is that instead of leaving it in the landfills and spoiling the beauty of the city, rather why not we make the plastic waste for making different kinds of products. If you go for a value-added products, upcycling, definitely you will have a much better margin. Rather going for a simple mechanical recycling, you may not get proper benefits or proper profit. And then if you see that only 25.7% is being recycled and 37.3 is incinerated, and 37%, which is nothing but 12.28 billion metric tons, will be discarded. Therefore, that much plastic is going to the landfills. That also makes it land available difficult, and then you are also, it is not a waste, it's a wealth. Therefore, you can make use of that waste for making the wells, and you can also make a lot of money. And in concluding that, I will say that if you do more and more recycling, it facilitates the clean environment and a lot of employment opportunities that, and especially the rag pickers. And if you see that in India, 60% of the plastic is being recycled, the credit goes to the rag pickers. But unfortunately, the dignity of the rag pickers is not that much, and we have to give a proper dignity to the rag pickers, because they are the one, they pick those type of plastic waste which nobody touches, and they make the environment much cleaner. And you can make a number of economical products, and newer products are also you can do that. Apart from that, it will also gives a business opportunity. And most of this problem also ends in your doorstep itself. If you try to segregate dry and wet waste, put all the wet waste in a biodegradable waste separately, then that can be composted in a manure, and the other one which can be recycled, put it in the dry one. If you do that, then automatically the major problem will go off. Another thing also, for example, if you see the PET bottle, the cap is made up of polypropylene, the body is made up of PET, and the label is PVC. Therefore, when you want to do a recycling, the PVC label has to be removed, the PP, you have to remove it. Therefore, now the new thinking is that instead of putting 3 materials and making a bottle, and then it makes, you have to do the separations when you want to go for a recycling. Therefore, now the idea is that they want to make a single material. That is, the bottle will be made up of only one single polymer material, rather putting 3 different polymers. Then that will also help the problems. Therefore, that type of thinking is going on. And these are the new scenarios, and a lot of potentials is there. And whoever wants to start up a recycling unit, they can very well approach the CPET. We are there to help them. And even some of our, even few of my students, they have become entrepreneurs, especially on the plastic waste recycling. And this is the one everyone has to do it, and they have to do it in a micro scale, because the waste is generated in different places. and moving those waste from different places to a bigger to a factory where they do a lot of recycling is very difficult, and then it leads to a lot of cost also. Therefore, my suggestion is that you try to do in your panchayat, in your local places, a small recycling units. If you do that, then the movement of the waste to a longer distance will not be there. Thank you very much for your patience hearing. And whoever wants to ask any questions, please let me know. I will try to address it. Thank you very much.
Thank you very much, Dr. PSG Krishnan. You have given us a very systematic approach. The awareness message is amazing. A lot of things to learn from your presentation. Question and answers, as I said, it will be taken at the end of the session. So now we will watch a beautiful song on single-use plastics brought to us by Bhamla Foundation, Mumbai. This is a chorus by many Bollywood singers and is less than 5 minutes. So let's watch that. Thank you. So I think Dr. PSG Krishnan, you will have to mute yourself and also your screen you can stop, you can unshare it now because Mr. Anup Kumar Srivastavji will be proceeding further. Thank you. There is no voice. Anupji, there is no volume. We're not able to hear.
हमारा
Yes, yes.
अगर सुन लो जो संभले ना हम तो बम ये फट जाएगा कि बहती सी है नदियां का ये पानी रुक जाएगा अगर सुन लो जो संभले ना हम तो बम ये फट जाएगा कि बहती सी है नदियां का ये पानी रुक जाएगा कि कर दो रहे धरती का ये दम भी घुट जाएगा कि कुदरत की नस नस में जहर ये बस जाएगा प्लास्टिक के हम सब मोहताज हैं कैसा ये समाज है कल ना हो हाथों में आज है मौका ये अब ना गवाए टिक 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 कसम ये खाए रे प्लास्टिक टिक ना पाए रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे सिचुएशन ड्रास्टिक है जहाँ देखो प्लास्टिक है सिचुएशन ड्रास्टिक है जहाँ देखो वही थैली बोतल स्ट्रॉ इत्यादि सर्रे सर्रे में फैला दी ना घट पाए ना मिट पाए रह रह के टॉक्सिक बन जाए इससे छुटकारा तो नहीं पर है एक सरल उपाय रे सिंगल यूज प्लास्टिक को हम कह दे बाय बाय रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे हम जो मिलकर ठान ले अगर वक्त ये बदल जाएगा कि इस धरती के कांधे से ये बोझा हट जाएगा Refuse to use, reuse, recycle ये नए रिवाज है प्लास्टिक वाले स्माइल सारे पूछ के आओ खुल के मुस्कुराए रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे टिक 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 कसम ये खाए रे टिक 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 प्लास्टिक टिक ना पाए रे
So wonderful, wonderful song, yeah. So now we move ahead with our next speaker today. So it is now time to introduce Dr. Asad Warshi, Advisor Sustainability. Dr. Warshi is working in field of sustainable development and circular economy since last 25 years. As an expert, he has worked on many prestigious national and international projects, policy formulations and advisory services to Government of India in many states. He has received many international and national awards for his contribution in the field of sustainable development. He is providing advisory services to more than 300 cities and towns in India. The highlight of his career has been to be project management consultant to Indore Municipal Corporation, which has earned Cleanest City of India title in 2017, 2018, 2019, and 2020. I now request Dr. Asad Warshi to kindly unmute and speak. Thank you.
Good evening, everybody. You are getting my voice, ma'am?
Yes, very clear, right?
Okay. First of all, I want to congratulate your organization and Anup sir for organizing such a beautiful webinar. And really, it's all the three professors and doctors, Dr. Mohanty, Dr. Bera, and Dr. From the CPET, all three really have thrown a very good light on the plastic waste management till date and what are the nitty-gritties of plastic. But I, being the person who is working on grounds and practically implementing this waste management projects, and that was my dream that at least in India we should have a city wherein we can say that we have proper waste management system. Starting from segregation to collection to processing and disposal. And that is how we succeeded in Indore. And as you know, since last 5 years, Indore is being declared as the cleanest city. And we started with, first of all, the concept of bin-free, dust-free and litter-free city. So as that we should not have any garbage collection bins And we should not have any dust on our roads. And thirdly, we should not have any litter. For the first time, we introduced the concept of this litter collection. That is the flying waste. Mostly it contains plastic and paper, light plastic, that is single-use plastic mostly, carry bags and all. So this is how we started in Indore. And thereafter, we started source segregation. So if we really want to succeed into this entire waste management cycle, and particularly plastic waste management, it is very important to convert it into a public movement. And that is where we have to come up with a awareness or IEC program, wherein we can create awareness on a daily basis. It's not so, yes, seminars and all this types of meetings are the prerequisite things, but thereafter, if we come up with a concrete plan, then it has to be a implementable, ground level implementable plan. And that is where we focused in Indore. And thereafter, now we have taken it to a number of cities, and we are trying to redevelop the Indore model, because in waste management, every city you have to come up with a tailor-made solution. They have their own peculiarities, they are their own systems and behaviors and everything. So the biggest thing is to bring about the behavior change and in the mindset of the citizens and the public at large. And that is where we focused in Indore. So when we talk of particularly, it's a long story, cutting short. For that very reason, because of shortage of time, and again, I have to leave, I have a meeting by 6 or so. So I'm not coming up with the presentation. I'm just sharing my ideas and important points, how we can take it forward. So when we talk of plastic, we have proper regulatory framework in our country. But the important thing is that we have to get it implemented on ground. And when we talk of plastic, I normally segregate plastic into two things, that is 2D plastic and 3D plastic. That 2D plastic means all plastic which is in film form, be it a carry bag or a wrapping film or whatsoever it is. And secondly, we have this 3-dimensional plastic. So what we did in Indore, that we have identified that the biggest problematic plastic is the single-use plastic or the 2D plastic. And where we have to focus in big way is the 3D plastic. So again, as many things have been shared by the various speakers, it is very important that we have to have a combination of this segregation, and thereafter we need automated. Yes, we need this rack pickers and all at the initial level. And that is what we have done in Indore, that even when we made this bin free, because when we make any program for government or municipality, it has to be social inclusive, wherein we should have a thought process to give employment to the person like rack pickers and to improve the quality of life also. So that is what we have done in Indore, that when we made this bin free, we carried out a survey of all the rack pickers, and then we established our material recovery facilities. We have 2 manual material recovery facility and 1 automated. And again, in automated material recovery facility also, the capacity of the automated material recovery facility is 500 tons per day. And whereas we have 2 manual material recovery facilities, each having capacities of 20 tons or so. So, and we employed almost more than 500 rack pickers. The purpose was that when they were initially doing this rack picking, they were just earning around some 125 to 150 rupees per day. Now, all these rack pickers, mostly as we know that females are there into rack picking, their minimum earning is around some 300 to 400 rupees per day. Some of them who are very smart and matured in segregation, they are earning around 1,000 rupees a day also. So that is where then we have come up with a bridge school for their children, because females were there, they used to carry them also, and then the cycle of rack picking continues. So this, I think this is one of the worst possible human employment, because they, as you know, in most of Indian cities, there is a lack of segregation. And when you mix particularly this organic waste, so organic waste started leaching very fast. And that is where they can get infections and all and everything. So they are the people, illiterates, who don't know why they have come to earth, and because of the reason they don't have any other employment, they are into this. So for that very reason, what we did, we came up with the bridge schools for their kids. And now I'm very happy to share with you that more than 100 children of rack pickers, they are into the main schooling now. And secondly, again, what we did, that we did the health checkups. Then we did, because they were all into our organized, we've tried to bring, when we brought it into the ambit of municipalities. So we did all this health checkup. We did that on a quarterly basis, health checkup of all these things, all these females and all the members, male members involved into this rag picking. Then we have provided them good all safety kits and tools and everything, safety gears to them. We have provided them good dresses also. Then what happens, this rag pickers, mostly, as you see, they get up very early, around some 4 a.m. or so, because they think of that they are doing some sort of theft by collecting this waste. So, and most of the time it happens so that even the sanitary inspectors and all the people also, they even sometimes molested them also. And secondly, they even take some money from them for the reason they are that this is the area, if you will do the rag picking, then you have to pay me so much. So these all things are happening throughout the country. So it is very important that for that very reason, we have to come up with a comprehensive plan for rag pickers also when we talk of this plastic waste management. Secondly, when it comes to plastic, it is very important that we have to identify the 2D and 3D plastic. And I always believe into working in since last almost 10-12 years into this waste management on ground, that we have to go for upcycling. Right now, whatsoever physical, mostly it's happening all this mechanical recycling, and that is again creating a lot of pollution. So it is very, very important that we should go with some good branded technologies, good technologies wherein least pollution is being done when we do this processing of or mechanical processing or even chemical processing of waste. Even in chemical processing also, as very rightly said by Mohanty ma'am, that many of Jugaad technologies has been emerged in our country because it's all in unorganized sector. So we have to bring all this into organized sector, and for that very it is very important then that through this EPR mechanism funding or through some government support, it is very important to develop state-of-art regional plastic processing facilities where we can, be it through a mechanical means or through a chemical processing, whatsoever the technologies, because now throughout the globe a number of good technologies are available wherein we can do very good upcycling, as told by all these 3 professors, that it is at most important that we have to develop the technologies which don't create, because after doing all this thing, if we create more harm to environment and if we release poisonous gases to atmosphere, and if we even pollute, if we generate a lot of microplastic which pollutes the soil and then it leads into the water and everything. So for that very reason, it is very important to take care of that. I always, whatsoever experience I have, I always believe into that we should have good regional facilities wherein this rag pickers and all should be involved. They should do the primary segregation. Then we should have a strong bundle pressing machine where we can make the bundles, and in a periphery of around 200 or 250 kilometers, the entire plastic from the supply chain should be collected and brought to a centralized processing facility wherein the quality processing is done. That will upgrade the recycling system also, and that will through that we can have good quality products also. So this is how we can do in Indore. We have done this. We have this automated material recovery facility. Then we have 2 manufacturing facility wherein this through mechanical processing, we are converting plastic into plastic raw material and making some products out of it. And secondly, we have come up with this chemical process also using the particularly that's all types of single-use plastic, and we are converting it into fuel, hydrocarbons, like fuel very near after distillation, all very near to diesel and petrol and all, furnace oil. So this is all possible, and it is all possible in India, subjected to if we have a proper will and if the political and administrative will is there to implement it on ground. So if we make a comprehensive plan, if we take it to government, and if government and all this big brands support us under EPR, then certainly it is doable. And that is what I expect. This is a need of the hour wherein we have to work hard on plastic. And secondly, again, we have to come up with a strong, stringent ban on single-use plastic. That is, again, is very utmost important. Even what is happening, that why we succeeded in Indore into this entire thing, That first of all, we worked on the behavior change of the citizens wherein they supported. Now we have reached to 6 bin segregation in the city. And almost 50% citizens are following this 6 bin segregation. Everybody means all institutions, all commercial, all offices, all citizens, be it a slum or be it a posh colony, everybody is following. And we are segregating this entire waste into 6 bins. Basically, the first is organic, the second is inorganic, that is dry waste. Third is plastic waste, segregating, and we are collecting on a bi-weekly basis. We are purchasing plastic from the citizens in Indore. And that is where now citizens are segregating the waste, because we are purchasing it ranging from 1.5 to 5 rupees a kg, depending on the quality of plastic. Thirdly, we are segregating this biomedical waste, that is the sanitary napkins, diapers, and biomedical waste generated at the household level. Then we are segregating e-waste, and then we are segregating domestic hazardous waste. That is all this containers, which paint containers and containers having chemicals. So religiously, this is being segregated. And I just want to tell you, give you an example, the level Indore has progressed is that when we started, 3 years before we started 3 bin segregation, that we started the collection of sanitary napkins, diapers, and discarded medicines. So we started with 20 kg. This year it has reached to 12 tons per day. So just you can imagine the quantum of waste, and if it is mixed with organic or inorganic, what potential it has to convert the entire waste into hazardous waste. So that is where now it is important to focus on segregation, and plastic processing also plays a very, very important role. But I always prefer to have good quality, good technology, centralized processing facilities instead of having this small jugaad techniques. So thank you very much for giving an opportunity. And certainly I will be in touch with your NGO and all the people. And I think the presentation should be shared to all the participants and everybody. So everybody can get enlightened and can learn from it. So thank you for giving me the opportunity. Thank you very much.
So thank you very much, Dr. Asad Washi, for briefly explaining us everything and giving us an insight of how things are working. Thank you so much. So
Thank you, ma'am. I have to take a leave because
yes,
by 6 again I have a meeting. So
okay.
it will take me 20 minutes to reach over there.
Yeah,
So,
Anupji needs to say something.
Yeah.
Yes, Anupji.
Yeah, I had to intervene because during the webinar, I got information that there was some emergency in the family of Mr. Sriraj,
Okay.
the fifth speaker. So he is not joining us. So you
Okay.
can skip that and move on to the next one.
Okay. So, so I now hand over to Shri Anup Kumar Srivastavji, Founder Director of CAP, for handling the question and answers. So you can start, Anupji, like with the question and answers.
Okay, thank you very much, Sonali ji.
Yeah, thank you.
You had right in the beginning announced that those who want to ask questions can put it in the chat box. There are a lot of messages on the chat box, but I find very few questions. I will take them up, but I have one major question to ask, whether Dr. Krishnan or Dr. Mohanty can answer it. The idea of converting a lot of PET plastic bottles into apparel and yarn looks very fancy. But I wonder what happens to the end of life of such apparel. What happens? How are these disposed of? How are these processed? And whether by doing this, are we only postponing the pollution, or we are actually attending to the problem effectively? Because if we postpone it, then the other day, then posterity will have to handle it. So is it a very good idea? Because after all, it is mechanical. If I've understood correctly the lecture of Dr. Bera, then it is not chemical recycling, but it is a mechanical recycling, the conversion into apparel and yarn. So can either Dr. Mohanty or Dr. Krishnan may please try to explain this?
Shall I try to answer?
Yeah.
If you see the mechanical recycling, it is easy to do it. And then whereas the chemical recycling, you have to do a lot of investment, and then that is one aspect. But if you want to make any food contact applications, for example, if you want to make a pet,
तुम्हारा आने वाला है।
you are making use of the pet, and later on you want to make again the pet bottle for the food contact applications, then the mechanical recycling is not the right approach. The chemical recycling, because you are going back to the basic chemicals. Why I'm saying is that because there is no control how the pet bottle is used. Somebody might have abused it, and somebody might have used it for putting a pesticide or some other chemicals, toxic chemicals. And if you do any mechanical recycling, because even if one bottle in 1 million bottles also, then that toxic will get into these things. Whereas the chemical recycling we did, and then we found out that even if the pet bottle containing any toxic chemicals, that if you do a chemical recycling, then we will be able to get rid out of that one. That we were doing it, and in future at that time we were making PET by chemical recycling it, and we were exporting to Pepsi. We were doing that, and they are ready to pay even because more money for that as a part of these things that we were exporting to them, making the PET by chemical recycling it. And then that we were exporting to the Pepsi. It is expensive than your virgin PET, but only thing is that you are getting rid of the PET waste. Whereas in a mechanical recycling, the toxic things cannot be removed it, because just you melt it and then do it. Whereas in a chemical recycling, you are going back to the basic chemicals, and then afterwards again you are doing the polymerization. Therefore, that is it, but it is a very expensive one, whereas the mechanical recycling is low cost in nature. I hope I have answered you.
Okay. Thank you so much. I find that Mr. Chitrak, I don't know whether he's present or not, but he has asked one question. He's asking, does LLDPE explicitly fall in the same purview as LDPE? And second part is there any difference in the recyclability potential between LDPE and LLDPE? So I don't know who will be able to answer this. Maybe Dr. Bera, if he is present, he can take it up.
Hello.
Hello.
The first question I would like to ask to Dr. Mohanty and Dr. Krishnan, as per the new EPR rules. So there is no explicit mention of LLDP anywhere.
There is no mention of LLDP anywhere, but you can amicably recycle it. That is not a problem. Okay, as per the EPR targets, if you might have seen, now government have allowed for, it has given a target of 2021, 2022, 2023, like financial year, 30%, 40% recycled content. Yes, you can amicably recycle both LDP as well as LLDP, but you need to take care of the phase separation and other things where technically it needs to be intervened.
Thank you, ma'am.
Thank you.
And one more question to both of you again is that under bioplastics, CPIT approves bioplastics and resins. CPCB approves compostable films.
Yes.
So
CPCB has given a certification for only compostable films. That is your PLA, PBAT starch, those kind of materials. Yes.
Yes, and CPIT approves for the resins.
No, it's like this. CPIT is basically a testing and a characterization laboratory. We test the compostability requirements. So what we do normally is that whatever compostable films you give us, any product, whether it is in the form of a film or it is in the form of any cutlery, cups, whatever it is. So that product needs to be tested as per ISO 17088. And then at the end of the day, if the type of the material, if it is passing the test, then we will release the test report. That test report you have to directly apply, go to CPCB and apply it for your certification purpose. I hope I am clear.
Yes, ma'am. So I also have something of a final CPIT report after 133 days. We have 90.04% of compostability as well as positive responses for all plant-based compostability. That's a final CPIT report that has been given to one of my clients.
Okay.
we have an interim report as well as a final report after 180 days of testing. As
Yes.
per BIS standards, we require CPET report, we require ASTM, we require EN, we require ISO 4 standards. So my question would be out here, is all this food contactable, or if it has any like hygiene products? You were speaking about some certain hygiene products. So when the hygiene products are in contact with these, does it differ?
See, for biodegradability or compostability certification, you have to go for CPCP approval. Okay. And other thing is that any hygiene related products, for example, if you have your sanitary napkins and other things, for that the body compatibility test needs to be done as per the approved standard that CPET doesn't do. CPET part is only of if somebody comes for compostability requirement, or if you have like other kinds of different tests like tensile, flexural, impact or other things, those things CPET can do it. And we will release a test report, you can go for CPCP certification. Any hygiene product, any female hygiene products like sanitary napkins or etc., those needs to pass as per the other criteria IS standard. You can contact Toxicology Research Institute or ITRC Lucknow, they do those things. I hope
Thank you,
I'm.
ma'am.
Thank you.
Thank you, ma'am. That was really insightful.
Okay, now I'll just quickly go through just a couple of questions with that. In fact, one Shrimati Smita Ganguly had earlier asked that don't you think that the product, she was referring it, addressing to Dr. Bera, don't you think that the production of certain types of plastics which are difficult or expensive to recycle should be phased out and looked for better for sustainable replacement? So I think in the subsequent discussion after she must have put this question, and in the discussion this question has been answered. But would you like to add anything, Dr. Bera, to this?
No. It's this has been discussed. I mean, if
This has been discussed and
this has
answered.
been discussed, but one also has to understand that. For example, I have if there is a plastic requirement for medical purpose, okay, and it's not a single use. You make something, then you use it for longer time. Yes, we have to do that. But there is another type of plastic, for example, disposable, medical devices that which you use and throw. So we have to. Someone has to banning something is not an easy decision. There has to be a lot of consideration go into it, and then one has to look at the pros and cons, and then take a decision. Anything that is banned, it's a policymaker decision. Many things has to be considered before such action is taken. Yeah.
Thank you. Then I find only in the last there was somebody. There are some observations but not questions. Only I'll take this last question of Mr. Abhinav Porwal, where he has mentioned that we are doing biomining of old waste and we are generating good quality refuse derived fuel. We have accumulated RDF, want to know how we can dispose it. Cement plant want to take RDF at negative cost. I will request Dr. Krishnan to take it up to try and answer this. And I will add to it, he was talking earlier about the pyrolysis technology in which you convert into fuel. That idea is also very good. Only unfortunately, I have seen it with my own eyes. I used to live in New Moti Bagh in New Delhi before my retirement, and such a plant was set up, but it has failed. Actually, it has very little use. Then I asked them, why don't you use it? They say it is very expensive, cost prohibitive and all that. So maybe you would like to throw some light. And this is the last question, and thereafter I will hand over to Sonali. Dr. Krishnan, are you there?
Yes, sir. Can you repeat, because I'm not able to hear properly. Can you repeat, sir?
Yeah, what actually somebody has asked, he has said, Mr. Abhinav Parwal, that they are doing bio-mining of old waste, and they are generating good quality RFD, that is refuse derived fuel. And they have accumulated RDF. They want to know how we can dispose it. Cement plant want to take RDF at negative cost. And I added my own observation on whether it is exactly this, but you talked earlier about the pyrolysis technology. Based on this technology, I have seen one plant which has been set up in New Moti Bagh Government Officers Colony, where I used to live till before my retirement. And I found that plant was not helping much, and it was not run. And very little fuels it was producing, and they were not able to put it to a good use. Then I asked them, why don't you do it? They say that, why don't you use more plastic waste? They say it is very cost prohibitive. So maybe you would like to add something to this.
And maybe they may not be able to use it, maybe for the want of the material, the plastic waste. That could be the reason. And if the cost is going up, what in few places they are doing is that, definitely I agree with that. Definitely the cost is somewhat on the higher side. Therefore, some of the industries under CSR activities, they are funding such type of activities, so that they take care of some of the high cost one. The first same thing, you can also explore some of the big companies under the CSR scheme. They can spend some money and make it economically viable. That's what in few places they are doing it. Under CSR scheme, they are funding it, so that even though it is on the expensive, they are able to do it. Maybe that type of model, maybe you can explore it, but only that you have to find a proper person who can fund you under CSR scheme.
Okay. Back to you, Sonali ji. So please go ahead.
There is one hand raised by Pratibha Bharati.
Oh, acha, I didn't notice. Pratibha Bharati ji, you can unmute and ask your question.
Yes, sir. Thank you so much. And it was a great session. Thank you so much. Sir, I'm an entrepreneur, a startup for manufacturing biodegradable and compostable bags in Hyderabad. So I just have a question to Mohanty ji, like CIPIT is having a regular test test of the material and the product at a certain period of three years or so. So I just want, sorry. Okay, so is this regularly testing that we are going for 3 years or so? Will have the same kind of charges or anything for the starting budding entrepreneurs that CIPIT or a CPCB is taking some steps to give them a backup for them to have at least a kind of sustainable life for them to go ahead, because lots of hiccups for the biodegradable and compostable compared to the plastic. We are doing a lot of research for the sealing, for the compatibility of the product they are using, and lots of other limitations are there, and successfully one by one we are trying to go ahead with them. But any kind of subsidy or any kind of help that CIPIT or a CPCB or the government has been is trying to take up, so that we can at least be a part of the revolution which we are taking for the plastic pollution, because we know the high price of the CIPIT fee for the testing is also like a big challenge for the startups or budding entrepreneurs who is coming into this particular manufacturing scale.
Dr. Mohanty.
Yes, sir. So first of all, 3 years test period, we do not know. So far, there is nothing called 3 years test period. The total testing period is 9 months. And 9 months, if you see, 6 months is your first interim report. And first interim report, in many of the cases, if you are using PLA or PBAT range of polymers, then within 84 days to 100 days, 90% disintegration is achieved. So after that, we go for a seed germination ecotoxicity requirements. So first of all, 3 years time period is not there. It is totally 9 months time period. Out of nine months, it can go still lesser if your product disintegrates faster. That is number one. Number two, for startups, for MSME, we give them 25% discount. Okay, based on the testing charges, we give them 25% discount for the startups as well as for the MSMEs. This is second point. Third point is that the cost of the test is very high. You cannot say it is high because if you go to other laboratories across the world also, the cost is predominantly high because the grades of the materials which is used, the time period of the test, and since it is a microbial degradation, so extra care is being taken so that your test continues without the death of the microorganisms. I hope I'm clear.
Sorry, ma'am. So is this the lifetime certificate that we get from CPET, or do we
Yes,
need to?
right now CPCB has made it lifetime, but we don't know, the rules may change. But right now, once you obtain a certificate for one product, then automatically it is lifetime. If it is a cutlery, one certificate will go on for lifetime. So that is what CPCB has made it now. We do not know because there are a lot of conceptions every time, the product, the material also people are changing. So those things are yet to be validated, but still, right, as of now, it is lifetime.
Okay. Okay.
Okay, thank you. I find one more hand being raised. Mr. Muhammad Atikur Rahman, do you have to ask something?
Yeah, thank you, sir. It's my great pleasure to talking to you guys. Can you hear me?
Yes, yes. We can hear you.
Thank you all the speaker, especially Dr. Bera, Dr. Mohanty, and Justin Krishnan. But due to the network failure, I could not attend the last session. But quite fantastic. There's not much asking actually. I want to know about few examples that Dr. Mohanty mentioned about the few practitioners that in Kerala they have a few eco-friendly practice. So if there is any chance that we can get the contact or get the details. So I'm Atik. I'm from Bangladesh, working as an environmental specialist in national organization which is called Anushakti Kids. Currently, we are doing a e-commerce, US based research, which is partnership with the Mumbai based organization, which is called EMC, Environmental Management Plan. And this is funded by World Bank. And hopefully, if there's any chance that we can collaborate with any research, currently we are doing other few waste management program in here in Bangladesh in a lot of cities, and I get to know about your sessions or your webinar through the CAC website, as I am also a trainer and doing some courses with CAC, so I get to know about from there. And I'm asking, not requesting, sorry, requesting Ms. Dr. Mohanty to share the information about the Kerala example, the eco-friendly. And thanks you all the organizer, and especially Dr. Vera, Dr. Mohanty, and Krishna. Thank you.
Dr. Mohanty, would you like to add?
Whatever recycling, that whatever you need from us as regards to waste management and recycling, we also encourage, because this is a research laboratory of CPET from where I am representing. So I have already shared my email ID. You can see in the chat box. I've already shared that. Please do write to us, and then accordingly, whatever assistance you need, because right now we are also assisting one organization. It's not organization, one company from Bangladesh in setting up of compostability requirements, and he is facing some technical requirements, pay problems as regards to characterization of bioplastics. So we are assisting and we are open to that. So whatever you need from us, please do write to us. I have already shared my mail ID in the chat box. You can take a note of it and write to us. We'll assist you. Thank you.
Okay, thank you, Miss. But as I said, due to the network failure, I could not attend the last session, so I did not get your email. And on the second or third session, third lecture, I have shared my details, my website, and other things. So yeah, thank you, Miss Mohanty.
I have already shared it once again. Please do write to us. We'll help you out. Okay.
Okay, thank you again, and thanks to giving me the opportunity to talk to you here.
Okay, thank you very much. And my question answer session is over. Now I hand over back to Sonali ji.
So we have almost come to the end of the program, and I request Srimati Uma Srivastav, who is a member of CAP, to kindly unmute and deliver the valedictory address and a vote of thanks. Thank you so much.
এটা একটা আন্টি আমার সাথে কাজ করছে।
Distinguished panelists, members of CAP, ladies and gentlemen, good evening. I'm Uma Srivastav. I'm a member of the Campaign Against Plastic Pollution Foundation. We have come to the end of a very fruitful webinar on plastic recycling, and the panelists have all been brilliant in their exposition. I'm sure all of us who have attended the webinar have learned a great deal. People who are some way or the other connected with the eradication of plastic pollution, like government officials, representatives of the State Pollution Control Board, NGOs, entrepreneurs, and others have attended to today's webinar, and hopefully all the lessons learned will be implemented by them in their respective capacities. I will touch upon some of the key lessons in short, and opinions and recommendations that have emerged in the webinar. It is generally accepted that maximization of recycling of plastic waste has to play a major role in mitigating the plastic pollution, although it is not the only thing to be done. Reduction of plastic use to the barest minimum and for essential items will ensure minimization of plastic waste to bring it within manageable limits. All plastics are not recyclable. Non-plastic should be phased out through research and innovations, as all our professors and especially panelists have mentioned. Our goal should be to reduce the requirement of non-recyclable plastics through change in our behavior and attitude. It is essential to ensure proper source collection. The garbage and the plastic litter should be collected at the source, and segregation of plastic waste for maximizing its recycling. There is need to segregate different qualities of plastic waste. Good quality of plastic waste should not be mixed with bad quality of plastic waste. The number of times a plastic can be recycled depends on each type. This also demands that different types of plastic should not be mixed with each other.
I request Mr. Mohammed Atiqir to kindly mute yourself, please. Mr. Atiqir Rahman Malik, can you please mute yourself?
I think as a host, you can mute him.
I would now like to express our immense gratitude to Dr. Jitendra Bera, Professor of Chemistry, IIT Kanpur, who has spared his valuable time to share rich insights about plastic recycling. Thank you, Dr. Jitendra Bera. Your presentation was really enlightening, and we have noted down all the inputs that you have given us. We sincerely convey our good wishes to you for your well-being. The presentation on single-use plastics, opportunities and challenges by Dr. Smita Mohanty, Director and Head, School for Advanced Research in Polymers, was extremely interesting. Dr. Smita, we thank you very much for sharing your knowledge and experiences. We wish you all the best in your career. Based on his vast experience at CIPET and earlier in the private sector, Dr. P.S.D. Krishnan made an excellent exposition about plastic recycling. For this, we are extremely grateful to you, Dr. P.S.D. Krishnan. And thank you for appreciating our logo. Thank you so much. I would now like to thank all those members of CAP who are present today and those who have been working with us relentlessly in carrying out our campaign against plastic pollution. I would also like to thank all the other participants who have attended the webinar today, and especially those who made the interaction all the more enriching with their insightful thoughts and questions. Last but not the, yes, I just thought Dr. Vasi has, since he has been busy. I would also like to thank Dr. Asad Vasi, Advisor Sustainability. His presentation and all his experience has been really noted, and it was a very, very enlightening speech. It was brilliant, and his long and rich experience is clearly visible. His positive contribution towards making Indore the cleanest city of India is really praiseworthy. We thank you very much, Dr. Vasi, for sparing your valuable time and enriching us with your knowledge and experience. Last but not the least, I would like to express our immense gratitude to Srimati Sonali Maini, who has moderated the webinar so brilliantly. No doubt she is an excellent moderator and spiritual mentor. Thank you so much, Sonali. Thank you all once again. Over to you, Sonali.
Thank you, ma'am. Thank you so much for your kind words. It's a great privilege.
Thank you so much.
Thank you. So now I declare the program is now closed. An evaluation form will be emailed to you later today. Kindly spare a couple of minutes to fill up the form and return to us via email as early as possible. So thank you, everyone, and good night. Hare Krishna. Thank you.
Thank you.